Hi Algebra 2B students, how you doing today? We are starting chapter 8, of course with section 8.1. After 8.1, we will be pausing to refresh our factoring before we go on to 8.2. So hope you are all doing great today. Today our lesson objectives will be solving problems involving direct, inverse, and joint variation, mostly direct and inverse. So variables are directly related to each other. If when one variable goes up, the other one does also. They are inversely related. If when one variable goes up, the value of the other variable goes down. And joint variation is when you have more than two variables related to each other. So we are first going to look at number 2. As you can see from the arrows there, let's see, the constant k in variation equations. We kind of needed to say that first before we went on to direct variation. So for number 1, direct variation, those will be very small equations that look like this, where k is your constant of variation that we saw on number 2. And that would mean as x goes up, y goes up. And as x goes down, y goes down. They are directly related to each other. Let's look at number 4, inverse variation. That is where you have y equals k over x, the constant of variation. Here again is k. Notice that the variables y and x are in inverse positions. One is in the numerator, one is in the denominator. Looking back to direct variation, notice that the x and the y are directly with the equal sign, both in the numerator. So for inverse variation, that means that as x goes up, y goes down, and as x goes down, y goes up. So now we can look at joint variation. That would just simply be when you have y equals k, your constant of variation, times x times z. In other words, y is related to more than one variable, and whether it's direct or inverse depends on the variable. Let's go down to our bottom box here. Direct variation, that would be an equation, again, that we already wrote in this format, where the x and the y are directly across from each other, and they would make a line like you see here. Joint variation would be y equals k, x times z, as we already wrote, and we don't have a graph here because we would need a 3-dimensional graph instead of 2-dimensional. In inverse variation, again, is y equals k over x, and that would actually have the look of these two nice curved branches. It does say do some examples with Miss Culver, so we'll just do a couple of those. Usually we do those in class, so let's take a look. We are going to say if these situations are direct and inverse. Usually I ask students. We'll do a few of these. Amount of desserts Miss Culver eats and Miss Culver's weight. Notice the more desserts I eat, the higher my weight goes. This must be direct. 2, the price of gum and the amount you buy. Just imagine that the price of gum went up really high. The amount that you buy would probably go way down, and that would be inverse. So these are examples of direct or inverse variations. Time studying and your grades. I think if your time studying went up, so would your grades. Time watching TV and GPA. I would think the more TV you watch, the lower your grades would be, because you aren't spending enough time with it, and that would be inverse, and that's kind of the idea there. Next page. We are going to try some of these problems, so let's take a look. Variation functions. So we are actually going to be looking for the words directly or jointly or inversely. So first we're going to do directly and jointly. Yep, we have one of each on the page. And so the first thing we're going to do is when you look up here in the box, a lot of times we don't look at the instructions because there's so much going on, but this is really helpful. Here's what we're going to do each time. We first find the word that matches the equation we need to use. It will be there every time, either directly, jointly, let's go to the next page, or inversely. You are looking for one of these three words. Then you will write the equation that matches the vocab word that you found. For direct, that would be y equals k times x. The next thing you do is they will give you an x and a y for you to put into the equation so you can find k, right? Because there's a lot of things that are directly related, right? But they have a different number that relates them specifically. So we write our equation, they give us an x and a y, we find the k, and we put it in. We now know more about our equation. The next thing they'll do is ask us to use our equation. They'll give us either an x or a y and ask us to solve for the variable that's missing. When you have variables that are jointly related to each other, you would write the equation y equals k times x times z. You will be given y and x and z, and you use it to find k. The next thing you do is put k in to that equation because you now know more about it. And the next thing they'll do is give you two of the variables that are missing and ask you to find the third. So let's take a look here, solve each problem. So we are going to break this into pieces. When I read number 1, if y varies directly as x and y equals 30 when x equals 20, find y when x equals 50. That sounds like quite a mess, but we are going to break our problem into steps 1, 2, and 3. So let's start. As y varies directly with x, let's stop right there. We see directly, we write y equals k times x. Step 2, we have to find k and put it in. And y equals 30 when x equals 20. See where this comma is? We're going to stop. They gave us enough information now to find k. Notice where there was a y, they put a 30. Where there was an x, they put a 20. We can now solve for k. I'm going to divide both sides by 20. There we go. And k equals 30 divided by 20, which is 1.5. The next thing we do, super easy, just update your equation. Y equals, we now know k is 1.5 times x. Okay, the last thing they'll do is give you a variable and ask you to find the other. Now you use your equation. Find y when x equals 50. So we need to put our 50 right in for x. Y equals 1.5 times 50. Y equals 75, and we are done. Let's try the next problem. Break it into 3 pieces. If y varies jointly as x and z, okay, need to stop right there. Jointly. There we go. We know what equation to write. Y equals k times x times z. There we go. Okay, let's keep going. And y equals 150 when x equals 2.5 and z equals 12. Okay, they just gave us enough information to find k. For the y, let's put in 150. We are trying to solve for k. For the x, let's put in 2.5. There we go. And for the z, let's put in 12. Here we go. To get the k alone, we could do some math right here, 2.5 times 12, or we could just divide both sides by 2.5 times 12. There we go. And when we use an ND or lots of good parentheses in our calculator, we get that k is 3. What do we do with that? Step 2, super easy. We just update our equation. Y equals 3 times x times z. There we go. Step 3. Now they're going to have us use our equation. Find y. Here's our 3 for k because we found it. When x equals 4 and z equals 6.5. Run that through the calculator and you get a 78. And we are done. Steps 1, 2, and 3. Next page, inverse variables. That's the equation y equals k over x. We are going to follow the same 3 steps. We might also be doing some graphing, which is nice. Okay, so here we go. Let's use green this time. If y varies inversely as x, let's stop. We see inversely. We write the equation for an inverse relationship. Y equals k times x. All right, let's move along. And y equals 2 when x equals 9. They just gave us enough information to find k. I'm going to put in 2 for y and x, 9 for x. Notice we'll multiply both sides by 9 and we get k equals 18. Okay, step 2, let's update our equation. We know that k is 18. There we go. Step 3, let's finish what they told us. Find y when x equals 6. So find y when x equals 6. There we go, and we get y is 3. Okay, let's go ahead and graph it. We could do a couple points on the graph, but let's put that in the calculator and see how it looks. So let's put in y equals 18 divided by x. Here we go, on our y equals screen. 18 divided by x. There we go, we can do a zoom 6. And we could just sketch this graph. You know, we have a curve in the first quadrant and the third, or you could go to the table and actually get a couple points going. Let's see. So I'm going to, in this case, I didn't realize my x was so big. I must have been using it for something else. So we're just going to give it a quick sketch, and next time we'll find some actual points on the equation to graph it. Okay, so I'll put that aside. We'll use that again. There we go. I'll just do a quick sketch. Okay, I just wanted to make sure we are going to do number 12 from your book and number 14 together on the back, just because these are great notes, but I really feel that if you opened up your book, you might find some problems that you don't understand as well, and we want to make sure that you can do that. So let's flip this over. You may want to pause the video and take a moment to write what I have, number 12, or you can just look in your book. The time t it takes for a salesman to drive a certain distance d varies inversely, let's underline that, as the speed r. It takes the salesman 4.75 hours to travel between 2 cities at 60 miles per hour. How long would it take traveling 50 miles per hour? Well, logically speaking, I can tell you it's going to take longer. So we're going to want to make sure that that when we find that time, that it really does take longer to go 50 miles an hour than it took to go 60, right? Our answer should be more than 4.75. Okay, but let's go back. The word inversely. Okay, so the first thing we do is write the equation. Now the problem we have now is, though, I don't see any x's and y's in here, so I am going to go back through. I'm going to keep my my equal sign here. I'm going to keep the form of the equation, but I'm going to go back through and replace my variables y, k, and x with the variables that they gave me. So let's take a look. Okay, the time it takes t for a salesman to drive a certain distance d varies inversely with the speed r. Let's go back, let's stop right there. Let's go back and read it and see if what we wrote, pretty much left to right, top to bottom, as we read it, fits. The time t it takes for a salesman to drive a certain distance d varies inversely as the speed r. There we go. I think we did a good job writing it. Okay, now in a different color, they're going to have us fill in the t and the r, and we're going to find the d. Okay, it takes the salesman 4.75 hours, that's our time, to travel between two cities at 60 miles an hour. Notice that they gave us the t and the r, and we can find the d and update our equation. So let's see, t is 4.75, d and r is 60. Let's multiply both sides by 60 to solve for d. And when we get that, d equals 285. Okay, let's update our equation in a different color. We now know our equation is, whoopsie daisy, not y, t equals 285 over the rate. Okay, I'm assuming, let's keep reading now. Let's read the last sentence, and let's see if we can use our new equation to answer their question. How long, that's time, would it take traveling 50 miles an hour? Okay, 285, and they gave us a rate of 50 miles an hour. Let's find out what that time is. When we do the division, it's 5.7 hours. We knew that it would make sense that it would take longer because they're traveling slower. So again, inversely, we wrote the equation that we knew. We went back through and read our equation and filled in with their variables, so it makes more sense to us. They gave us the time and the rate for us to find the distance. Instead of k, we were using d, and we put it in. We updated our equation, and then they asked us to use it. They asked us to find the time when the rate was 50, and we did. On number 14, here's our last problem. You will find problems where they give you a chart, and they ask if this set of x's and y's are directly or inversely related, or neither. So here's how you do this. First of all, we have to decide if it's direct or inverse. Direct or inverse. Let's take a look. For direct, the variables change the same. For inverse, they change opposite. When one variable goes up, the other goes down. Let's take a look. 6, our x is 6, our y is 2. Notice that our x went down and our y went up. Notice our x went down and our y went up. So if this is going to be any kind of relationship, it will be inverse. But we have to check and make sure that's true. Okay, how do we do that? Here's how we check. Okay, we believe it might be inversely related. Let's take a look. Every time, let's put in the x and the y they gave us and find the k. For each set of points, we're going to do this 3 times. Okay, here's our first set of points. Our y is 2, and our x is 6. Let's multiply both sides by 6. Our k is 12. All right, let's try the next point in green. Y equals k times x. Our y is 3. Our x is 4. Let's multiply both sides by 4 to find k. K is 12. Let's do the last set of points. Our x is 1, our y is 12. Let's put 12 for y, k for 1. We can multiply both sides by 1, but we don't really need to. It says that k equals 12. So yes, this is an inverse relationship because the k remained constant through the entire set of data. And that is section 8.1. I hope you have a great day.